titrations. Titrations are using acids and bases to determine unknowns. So it is still an acid-base reaction. We have some acid, some base, and we are producing water and a salt. I just saw that in this picture they put a capital L for chlorine. Oh, that's so bad. Don't do that. So titration is finding a point at which the number of moles of your hydronium ion equal the number of moles of your hydroxide ion, so that you can calculate then the equivalent molarities. So we usually use it to determine the unknown molarity of the solution. So if we don't know, like if we have the molarity of an acid, but we don't know the molarity of a base, we can titrate them to calculate it, or vice versa. What is known, or at least what's going to be known in our experiment, and what is typically known, is the molarity of the standard. So whatever we put in the burette is what we call the standard solution. The volume of the standard. So again, in the burette is going to be one of the solutions, the acid or the base, but we call it the standard. And then you're going to fill it up to an initial volume. You're going to record that initial volume, and then drop by drop. That's what this thing is here. It's a stopcock, and you can open it so that you only go drop by drop. You're going to put drop by drop into the solution, and then when it reaches its end point, you're going to see how much volume was used up. So you'll know the molarity that you put in the burette. You'll be able to read the volume that you used from the burette, and you'll also know the volume of the solution that's in the Erlenmeyer flask. You're going to measure out a very specific volume. So then the only thing you don't really know is the molarity of that solution, which is what it says over here. What is unknown, or what are you going to calculate? You're going to do solution stoichiometry in order to calculate the molarity of the solution in the Erlenmeyer flask. There's a couple of vocab words here. So equivalence point and end point. Equivalence point is the point at which the moles of the hydroxide ion and the moles of the hydronium, so the moles of the acid and the moles of the base, equal each other. That's going to be different depending on, what the mole to mole ratio is, and weak and strong and all that stuff. But in general, that's what you're looking for. The end point is a lab term, and the end point is the point at which the indicator changes color. So we're going to be using phenolphthalein, which turns pink when you get just past equal amounts. So here you can see in this first Erlenmeyer flask, you can see a starting point where nothing's mixed. And then as we add standard into our solution, it will turn pink, very localized like this. And then as you swirl it around, that pink color will fade and sometimes completely disappear and go back to looking like the starting point. We add a little bit at a time until that pink lingers. So we're going to shoot for a very light colored pink. If you get a very dark pink, it means you put too much of the standard into your Erlenmeyer flask. Sometimes that end point is a very, very sharp point. So one drop will make it like bright pink. It's not the easiest thing to do, but it is a lot of fun. There are obviously calculations associated with this. Those will be linked into your notebook, and I'll do some in person. But if you have any questions about titration, please let me know.